Hello. Our project is limits and continuity on piecewise functions and greatest integer functions. This was made by
Me.
and me.
Prior knowledge necessary to understand piecewise functions include graphing with domain restrictions, how limits work, and what discontinuities are, the what, the why, and the how. A piecewise function is a function which contains multiple functions each with a certain interval on the main function's domain. Why? A piecewise function allows one to view discontinuities not only graphically, but also solving for them algebraically. Students can tell continuity of a piecewise function through algebraic substitution or graphically. Common mistakes that students make. Common mistake that students make is possibly confusing the non-removable and removable discontinuities. Another one is messing up the open and closed circles that are used to represent. Okay, just cut that part out. I was going somewhere, but I don't know where.
Just leave that in.
Here's one example of a piecewise function problem. The question presented is this function continuous? Piecewise function is f of x equals 2x squared minus 2 when x is less than or equal to 0, and f of x equals 5x when x is greater than 0. Now to simply do this problem, we substitute 0 into both these functions, or these sub-functions, and we find the results. You will later see that these results are not equivalent, therefore this function is discontinuous at x equals 0. This particular discontinuity is a non-removable discontinuity. It is more specifically a jump. Non-removable discontinuities also include vertical asymptotes, while removable discontinuities also include holes.
Now we're going to move on to greater integer functions. Some prior knowledge a student should know include how piecewise functions work, how limits work, what discontinuities are, and especially jumps. What, why, and how. What? A function that for every real number x, f of x is the greatest integer less than or equal to x. Why? Greatest integer functions as a form of a piecewise function allows one to see the stepping relationship of things that cannot be put in decimals, like population. How? Students can see how the greatest integer function rounds down to a real number and to the nearest integer, hence the jump. Mistakes. 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 Some common mistakes with greatest integer functions include graphing the transitions wrong, messing up on the open and closed circles, and messing up the direction of where it approaches from. Going straight into the example, it is obvious that transformations are at play. The 1/3 in the middle of the graph represents a horizontal stretch, while the -2 on the outside represents a vertical shift. Here's a list of other transformations that could also be at play. Feel free to pause the video now. Now, as you can see, all we have to do is simply read the graph. And in the first question, it says that it is approaching 1 but does not specify which direction it comes from. So we can only assume that it is going to -2, which is in the middle of the line. In the second question, it does specify, and this time it is going towards 3 from the right direction. So we now know it is going to 1, -1. It is 12 o'clock. 12 a.m. to be exact. What are we doing?
Good night.